Another situation when I can guarantee that my system will have a solution is when the right-hand side are all zeros, and in that case, I can actually just say that if all of my variables are zero, then this is going to be a solution for sure. So at least I can find one solution to this system. In this case, the system of equation actually has a special name. It is called homogeneous, and that's going to be when the right-hand side, the vector b here is 0, and I can guarantee that they are going to be solvable because the 0 vector, when all my variables are 0, are going to be a solution for sure. Now, if I were to carefully solve these two systems, though, the first one, my matrix here, is going to be 1, 1, 1, 2, 1, 3. Now then, I can subtract the first row from the second row and from the third row. So I'm going to have 1, 1, and then 0, 1, and then 0, 2. So now I can subtract the second row. Wait a minute, I forget the 0 on the right-hand side. Let me actually move this a little bit. I'm just going to insert that into here. So my right-hand side are all 0. Notice that the right-hand side, because they are all 0, so it doesn't really matter anyway, because no matter what we do, it will always be 0. Now then, I can subtract the second row from the top row. So I'm going to have 1, 0, and then 0, and then second row stay the same. And I'm also going to subtract 2 times the second row from the third row. So I'm going to have all 0 here. So this is my reduced row echelon form. And I can see that my x is going to be 0 and my y is going to be 0 as well. And for the part b here, well, this is already in reduced row echelon form. My x, my y, and my z are all going to be 0. So these are the only solutions that we have. Now, for the last two, we actually already find the reduced row echelon form for this guy in the example 1.7, part C and part D. Although we actually only find the reduced row echelon form for matrix A, but because the right-hand side are all 0, so it doesn't really matter anyway. The reduced row echelon form for this system is going to be 1, 0, 1, and then 0, 1, 3, and then 0, 0, 0, and my right-hand side are all going to be 0. And for part D, I'm going to have the identity matrix, and then the right-hand side are all going to be 0. So for part D here, the solution is going to be my x, y, and z are going to all be 0. My y and my z are all going to be 0. But for part C here, because I have my x and my y to be dependent, but my z is going to be free. So this guy is free. So my z can be anything. So my z can be anything. And then my x plus z has to equal to 0. So x is going to be just minus c. And then y plus 3c is going to equal to 0. So my y is going to be just minus 3c here.